Okay, hi everyone. I'll be going through this paper with you. So if you can get ready, your practical, let's begin. My advice to you when you get the practical paper is to look at the list of items, apparatus given to you and check that you have everything. After that, quickly read through all the instructions. Okay, read through all the instructions. Don't do anything yet. Read all the instructions. Have an idea of what you're supposed to do. Plot graph. Okay, read all the questions. I'm supposed to look for G. So this experiment is to look for G. And after that, I'll be asked to do some calculations. And after that, there are some questions for me to answer. This part requires me to look for an error in the experiment. Okay, so now I have a general idea of what the experiment is like. Then I carry on. Okay, whatever the experiment is going to be for your practical, please look through the entire paper, just like your comprehension. Okay, now let's begin. How I mark is, I will look at your table of values. Okay, so the first thing you might see on your script is this T, the P, this C, and this C. Okay, so what I'm going to do is to check. This T is for trend. I am going to look at your values. As the L decrease, do your numbers over here decrease as well? If they do decrease, then I am going to give you the mark for T, for trend. Okay, I don't care what your values are. As long as you show me a decreasing trend, you are getting the correct, you'll be given credit for this. Okay, next, DP. The question tells me that T1, T2 are supposed to be recorded to 1 decimal place. So I will check your T1 and T2. T1 and T2, very good. All to 1 decimal place. Then I see 23. I suppose you have 23.00 on your stopwatch, but this is not acceptable. So once I see this, I expect 23.0. Once I don't get this, you will get a cross for DP because instructions were not followed. Okay, even if you have this, I will continue to look at this. Okay, how does this T average obtain? Question says find the average time for 20 oscillations using this and this. I want to find the average of this and this, which means the T average is obtained by taking T1 plus T2 divided by 2, the average of these two values. Since these two values are recorded to 1 decimal place, everything here should be in 1 decimal place. So this one, and this one would be marked wrong. So again, you get a cross over here if you didn't follow. The next thing I'll check is capital T and capital T square are to be recorded to 2 decimal places. I check 2 decimal places, 2 decimal places. If you fulfill all these things, you will get a tick for this DP. Next thing, I need to go and check, I'll check your values for this calculation of T. This C stands for the first set of calculation. How do I obtain this T? This capital T is obtained by finding the period of the pendulum. Period of the pendulum means time for 1 oscillation. What do I have for T average? This is the time taken, average time taken for 20 oscillations. I want to find 1 oscillation. What do? Take this number, divide by 20. So I'm going to check each and every one of these values. Okay, if they are correct, then I am going to put a tick. Okay, then the next one is, I got another C. This C stands for the calculation of these values. How do I get this T square? Instruction says find the square of the period. The period I found here. The square of the period, I take this number, multiply by itself, 1.93 square, and I'm going to check each and every of these values. Okay, unfortunately, one of the values here is wrong. Okay, I will check all the values. Okay, and since it's wrong, this person will get no marks for this. And as a result, the whole table, the student will get 2 marks. Okay, if I had no error here, I would have gotten 1 more mark. If I calculated this carefully, I would have gotten 1 more mark. So this student could have gotten 4 very easily at first, but no. Silly mistakes are made, and so 2 marks was lost. Please take note, don't let this happen in your actual practical. Now let's look at the graph. I'm supposed to plot a graph of T square against L. Please take note, T square against L, this is Y, this is X. That means, this is the Y-axis, T square is here. This is the X-axis, L is here. When I mark, I am going to check. When L is 30, T is 1.35. So I am going to check 30 and 1.35. So this is okay, okay, okay. I will check every single point. Okay, if all these things are correct, you notice that there is a P, you get a double tick. Why double tick? For all correctly plotted points, you get 2 ticks. If there are some points you plot inaccurately, you might get just 1 tick. If you plot all your points inaccurately, you don't get any ticks. And you might see an S. This S here stands for scale. Okay, my x-axis over here, I look at my graph. I occupy 30 to 90. This is more than half of the entire axis. So over here, good scale. I look at the y-axis. I come from 1 point something, 1.5, all the way to 3.5. So this portion occupies more than half of the entire scale. That is good. So scale, 1 mark. Some of you had graphs looking like this. This is your entire graph paper. Your line looks like this. So there's an entire worth of space here that is not utilized. So this is wasted, and if you have a scale looking like that, you will have a cross for S. Lastly, I'm looking for a line of best fit. Line of best fit means a line that passes through most of these points. Okay, some on top, some below. Let's look at this particular example. This one is on top, 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 this one is on top. So everything is on top. This line is not a well-drawn line. Although one look, you may see, wow, falls very nicely on the line, right? But no, I must push everything up so that I get equal number on top, equal number below the line. So this person is not going to get the score for the line. Out of 4 marks, this student is able to get 3 here. How do I improve on this mark? Please adjust the line so that I have same number on top the line, above the line I mean, and same number below the line. Next, calculation of gradients. Some of you basically went to use y2 minus y1, y2 minus y1, x2 minus x1. Very convenient. Okay, then if that's the case, we don't even have to draw a graph to begin with, right? The question says, using your graph, find the gradient of your graph. So I'm supposed to go and choose 2 points on the graph. My recommendation is choose a large triangle that is formed from points that are easy to read. Okay, so over here I can see, over here 35, and I look to the left, 1.5. This is a nice coordinate, easy to read. Look for another one over here, look all the way down, this is 85, this is 3.5, good, easy to read. To find gradient, use formula. Nobody's going to tell you this formula in the exam, so please check. Substitute the values correctly, simplify, and my answer, many of you gave 0.04 for some reason. Okay, that is not accepted because these are calculated values experimentally. I obtained these values from my experiments. This answer should be quoted to 3 or 2 significant figures. So this is the correct answer. Okay, if you had a graph that was not like that, I will still look at your working. If you follow my set of working, meaning I choose 2 points, and then I go and calculate the gradient, you are still going to get 2 full marks if you have done things correctly. Your value may not be near this, okay, as long as you've done it correctly, you'll be getting the full marks for this portion. Okay, let's look at the last portion. Okay, I'm asked to go and find the value of G, which is the gravitational field strength. In class, we learned that G is equals to 10 Newton per kilogram, okay, or 10 meter per second square. So roughly in my mind, my value should be about 10. So let's go and substitute the value. Some of you asked during the experiment, what is this? Pi, okay, this is pi. What is the meaning of pi square? I press pi times pi on the calculator. Okay, whole thing divided by 25. 25 came from here. Where did this 0.04 come from? It came from the gradient. Gradient from my previous page, 0.04, 0, 0. So over here, I expect to see 0, 0. If that wasn't given, marks will be deducted. Okay, some of you had a wrong gradient over here. Your value of gradient was very terribly off. It's okay, you will get an error carried forward here. But if your values are like 300 meters per second square, this is way off. Okay, and then you will get 1 mark deducted for accuracy. In a practical experiment, usually you can expect about 1 mark to be given for accuracy. Okay, lastly, I'm asked to find percentage error. Experimental value means the number I obtained from my experiment. The theoretical value is the one that is given in the textbook. Okay, in higher level physics, theoretical value is usually given at 9.81. Okay, so this is given 9.81. Please substitute all these values carefully. Calculate carefully. You get 1 mark. Okay, a few of you missed out this 100 for some reason, and if you miss out the 100, you miss out the mark. Last question. Describe one source of error. Please take note, questions like that are asking you for improvements to the experiment. If you tell me the length was not read at eye level, there was a pendulum, you're supposed to go and measure this length using the meter rule, right? This is the meter rule, and some of you can say, oh, my eye was here, so it is not read at eye level, you get parallax error. Okay, fair enough. If there's a parallax error, then my question to you is, why didn't you read carefully at eye level during your experiment? This error that you quoted can be resolved easily. Okay, so that's why answers like that, read the length at eye level, these answers will not be accepted because you are already expected to do it. Okay, so what kind of errors are accepted? You can tell me as the pendulum is swinging. Okay, I am not exactly sure when to start or stop timing, because do I stop when the pendulum is here? Do I stop when the pendulum is here? Or do I stop when the pendulum is here? Okay, you may say, oh, stop when the pendulum is here. Then, when exactly is that? Okay, there might be some small changes that I'm not aware of. Maybe 0.01 second. Alright, so there could be human reaction time. How do I reduce this human reaction time error? Okay, so the experiment told us to take the time for 20 oscillations. Okay, let's say my error is 1 second. 1 second out of 20 oscillation is quite significant. Okay, how do I make 1 second less significant? Instead of doing 20 oscillations, I can change it to maybe 40 oscillations. Can you see that? 1 out of 20 compared to 1 out of 40. The 1 becomes less significant already. So my error becomes reduced this way. Okay, so there are other acceptable answers. So please take a look. This student is going to get 0. Okay, so 2, 1, total 3. 3, 2, 5, 8. 8 plus 2, 10. This student is going to get 10 upon 15. Okay, so this is how it's usually marked. Please check your answers. Okay, and if there's anything that you're still unsure of, please look for the teachers, Mr. Thong or myself, Mr. Lim. Okay, or some physics teachers that you are comfortable with, and then clarify your doubts. Alright? All the best for your prelims this coming Thursday.